Hello to everyone watching this video. Today we are going to focus on problems in closed vector diagram, how to answer the questions on a closed vector diagram, how to draw a closed vector diagram. So this is the focus for today's video. For example, if we can look at this question, let's look at this question. So in this question, there is this box which is 15 kgs, and this box is pulled in this direction by this force until it stops. So njengoba istophile pha, the forces here balance, the force right here balance and the force left. So xa forces balance, the F net is equal to 0. So F net wethu lingana no 0 newtons. F net onjani? The resultant force vertical and resultant force horizontal. If you can look here, we have this landed force. There is a force in the string which is known as a tension, which is going up. So there are components. Here we have the components, that is the y component, which is ty. Then we also have the x component, which is tx. So if we focus on horizontal forces, the net force there is equal to 0. If we focus on y forces, vertical forces, the net force there is equal to 0. And you will remember that everything in the universe will have Fg. So we have a weight for this box. So we are going to focus on a closed vector diagram. After that, we are going to answer the questions here using the closed vector diagram, not the component method. Components lab. We are going to use the closed vector diagram. Use ezosinceda to answer these questions. So let's go straight to it. Let me remove the question. Okay, let's try to explain. Yeah. Let's say the object is hanged there. Now the object like lebesinayo. Then we have the force that is applied, that is force F. The first thing here is to draw the free body diagram on this box. When we draw the free body diagram there, we will have obvious Fg, which is going down. The weight is going down. Then we have the force on the string, which is known as E tension. Then we have this force, that is force applied. So since forces it was Z3, and we have E angle here, for example, or not there. Let's make it easy. Let's have the angle between the vertical line and the tension. Let's say the angle here is 83 degrees, for example. So it will question you must draw the closed vector diagram. In fact, bala any question here, you must first draw the closed vector diagram. So if usingajonga apha we have tension. If we want to calculate the tension, let's draw the closed vector diagram. We have the force applied. We must draw the closed vector diagram. But this one you must ngayibala by mg. Let's start with it. Fg is equal to mg. So imass yethu ngu-2, therefore uG it's 9,8. Constant uG sibe no 19,60 newtons. So it's no 19,60 newtons ongu-Fg. Okay, So let's move this one to this area. Let's put it here. Now let's go back to the closed vector diagram. Now that we have the free body diagram, I said you must first draw the free body diagram. This is the free body diagram. This is the tension. This is FG, which is going down. The bullet is the object itself. So the object here. Then when a force which is a force applied. When you draw a closed vector diagram, tata le migca uyi-rearrange, but make sure that umgca omele u-F uzoba horizontal, uya e-left, umgca uzomela u-tension uzonyuka aye-le, then omele u-FG ehle ezezantsi. Let's rearrange. Masizobe ngole closed vector diagram. So we have force eyale, which is a tension. Then we have force ezantsi, which is FG. We have the force a left, which is what? A force, that is F. This one is FG. This one is tension. So let me draw it. Let me make it bigger. So we have these forces, the downward force, which is going down. Then we have force ALE, which is force applied. Then we have tension, which is going in that direction. So this one is a force. This one is FG. This one is a tension. So it's many angles. This one is vertical. This line is vertical, and this line is horizontal. Therefore, here 90 degrees. Vertical force is perpendicular to horizontal force. Then we have this angle. Now let's go back. Lapha sinalo umgca wehlayo lo enza i-angle engubani engu-40 engu-83. Sinalo umgca wehlayo nalona umgca. So sinalo umgca we-tension nomgca wehlayo. I-angle between umgca wehlayo straight ne-tension ngu-83. I-angle between umgca owehlayo straight ngubani ne-tension ngu-83. Now if ngu-83 lapha ngu-90, the sum of angles of a triangle is equal to 180. So we have 83 plus 90 degrees plus the angle esingayaziyo, this angle. Let's say that angle is theta, which is equal to 180. Then sicofe i-calculator yethu. Sibomba izosibeka phi i-calculator yethu. 180 minus 83 minus 97. So we have the angle which is equal to 7 here. So we have 7 here. 7 degrees. When you combine all these forces, you get 180. So this is the closed vector diagram yethu. So let's remove this and this, because we're looking for a closed vector diagram. So that's sizobala. Closed vector diagram, sizobala. This is our closed vector diagram. What is this now? So this is our closed vector diagram. Let's take it to this area. Now the question will say calculate the force applied or calculate the tension. We already calculated FG, which is 19,60 newtons. When we want tension, we are going to use this triangle. There are many methods, but the one I like the most is a sine rule, because what grade 11 niyayenza a sine rule. The sine rule ithini? Angle A, sine of angle A divided by the side that is opposite to A is equal to sine of angle B divided by a side opposite to OB. That is sine rule. So we do have FG, which means we always refer to FG. Let's calculate tension. I-tension yethu nansi i-opposite to AP angle. Le angle ngu-90, which means we are going to say sine 90 degrees divided by tension opposite to 90, because sifuna tension. Yintoni esinayo? We have FG now. FG. U-FG and opposite AP angle, angle ingu-7. Sithi sine of 7 degrees is equal to FG ongu-19.6. Sele simbalile. Then we solve for T. When we solve for T, we can cross multiply. Let's cross multiply. This multiply by that, and this one will multiply this one. So we have T times sine 7 ibe ngu-T sine 7 degrees, which is equal to sine 90 times 19.6 ibe ngu-19.6 sine 90 degrees. Then sidivide into esingayifuniyo kweli cala. Asimfuni usine 7 abe kweli cala. What you do on the left hand side, you must do on the right hand side. So this cancels that. Then the tension is equal to, let's press the calculator to get the tension. The tension now is equal to 160,83 newtons. Then the tension is solved. Now the question says calculate a force, this force that was applied. That force is opposite to 83, which means if we are looking for that force, we will use 83. So sine of angle 83 degrees divided by the force sifunayo, because opposite to 83. Then if we want to use FG lo besimnikiwe, we'll say FG is opposite to 7, sine of angle 7 divided by FG, which is 19.60. Then what do? We cross multiply. This multiply by that, this by that. So F times sine 7 is about F. So is about F. That will be F sine 7 degrees, which is equal to sine 83 times 19.6 is about 19.60 sine 83 degrees. Then it's divided by sine 7 both sides, sine 7 degrees. So this cancels that. Ashiyeke F elingana. Then we press the calculator. It's 19.60 times sine 83 degrees divided by sine 7. Then we get the angle a force which is 159.63 newtons. So sibe sizifumene zonke ii-forces esizifunayo. Then let's look at that question. What was asked in that question? Let's go straight to that question. Now let's look at this question. We are given the statement which says a billboard mass 15 kg is suspended from the roof by means of light in extendable string. Force F pulls the billboard sideways as shown in the diagram. So if we can look at this one, we have this force. We have this force on a string. So siyazi la force is a tension, but call le angle. Before sibale whatever, masiqa sifumane angle between a vertical line and the slanted line force, that is tension in this case. So funeka sifumane le angle. Singayifumana kanjani le angle? Le ndawo yonke ifamba ilingana no-90 degrees. 90 degrees, but sino 40, which means apha ngubani ku-50. So we say 90 minus 40, then le ndawo ithiwe ngubani ibe ngu-50 degrees. We are going to use 50 degrees kuzo zonke ii-calculations zethu. U-40 yona akasangeni indawo ngoku, out u-40 masimcike angabikho. Sifuna i-angle between the vertical in this case and i-force le sithetha ngayo ngelo xesha. So the first thing is to draw the free body diagram, but let's finish up the statement. This one is 15 kgs. Then we have a force that is applied when the angle between the roof and the string is 40. A closed vector diagram is obtained, which means F net is equal to 0. F net is equal to 0 because the closed vector diagram is obtained. Newtons, F net is equal to 0 newtons. What deduction can be made when the force acting on an object forms a closed vector diagram? Loo nto isixelela that the net force is equal to 0, okanye the forces are in equilibrium. Net force is equal to 0. Net force is equal to 0. Calculate the weight. Let's calculate the weight. Let's answer the questions as they are asked. Let's calculate the weight. That is 2 marks. Let's calculate the weight. So the weight is calculated. In fact, in our case, weight is Fg is equal to mg. The mass is 15 times 9,8. Then let's press the calculator. 15 times 9,8 is 147. So the weight is 147 newtons. That is Fg. So Fg weight is 147. This is 2.2. Question 2.2. 2.3. Draw a labeled closed vector diagram. Okay. Indicate the value of one of the angles. Let's draw the free body diagram. Let's start with the force diagram. So there is a weight here which is going down, that is Fg. Then we have this force going that direction, that is a force applied. Then we have this one. So the free body diagram is the tension in that direction. Then we have this force in that direction. Then we have Fg in that direction. But the question says, calculate the closed vector diagram. Now let's draw the closed vector diagram. The closed vector diagram is drawn from a free body diagram. Start the mixture as it is. C combine it to make a triangle. So we have a force that is going in that direction. Then spin on a force which is going down. Then spin a force A that is force applied. Okay. Then here there is 90 degrees because horizontal is perpendicular to vertical. So spin an angle la, spin an angle la. This is Fg. This one is a force that we're talking about. Then here is a tension. So to get the angle, umgca owehlayo no ne-tension zenza u-50. Umgca owehlayo ne-tension zenza u-50. So we have 50 degrees to make 90. So here is 40 to make 180 because it's 90 plus 50. It's 140. then we need 40. So sesizigqibile siyiphendula question. Let's check another question. The following question says, after we have drawn the free body diagram, the closed vector diagram, the following question says, this one, I don't know what is happening here. The following question says, calculate the tension. So the focus is on the tension force now. So Fg is already calculated. Up there is 147. Fg is 147 newtons. So we are looking for a tension. The tension is opposite to 90. Therefore, we are going to use 90. Sine 90 divided by the tension is equal to, we have Fg which is opposite to, this is Fg, this side is Fg is opposite to 40. Therefore, we're going to say sine 40 divided by Fg. Fg on 147. Then we cross multiply, then we are done. So let's cross multiply, we will have T sine 40, which is equal to sine 90 degrees times 147. Then we divide both sides by sine 40, because sine 40 is in phone, sine 40 degrees, this cancels that. Then we get the tension. Let's press calculator to have the tension. So calculator here to, so the tension force is equal to 268 newtons. Then we answered this question. The following question says, calculate the what? The magnitude of force is equal to the magnitude of the horizontal component of the tension. So the magnitude of force F is equal to the magnitude of horizontal force. We have force F, which is in this direction. Then we have the component, that is Fx, in that direction. They are equal in magnitude. Give a reason why these two forces are not considered to be the action-reaction pairs. Kaloku action-reaction pairs zii-forces, action-reaction pairs zii-forces ezisuka kwi-object ezingafaniyo. So apha ngozisuka kwi-object eyi-1 awuzuba zii-action-reaction forces because zisuka kwi-object eyi-1. For example, if you have udonga, the wall, and you have maybe the book, you compress the book there. We have, let's say you also have the force that is applied by the hand. So the action-reaction force is there because we have the object as means. But in one object, there is no action-reaction pair. It is because these forces are from one object. They are from one object. Therefore, they are not action-reaction forces. Thank you.